Hello and welcome to this session of Groundbreakers Live. I'm your host Javed Mohammed, and very honored to have with us Hugh Mckee, who is a developer advocate at Lightbend. Hugh, welcome.
Thank you. Pleasure to be here.
Thank you. All right. So you're going to be presenting at Dev.Next. The title of your talk is The Evolution from Monolith to Microservices to Serverless and Beyond. I'm very interested in the beyond part, but let's help us walk us through this evolution. So, what's kind of driving this?
A couple of things. One is that there's so much spectrum, depth to where all of us are at the moment. With I speak at a lot of conferences, or I did. And you run into people that are doing, say, serverless. They're kind of at the leading edge. Microservices has been a big thing for the last couple of years. And then, for example, I grew up in a monolithic world before I came to Lightbend and started to get into distributed computing and so on. And in my travels, which I'm lucky in the role that I have, I get to meet so many people. You see, they're all over the map. And there's what I kind of call the lucky ones that are way out having fun, say, in serverless, really doing something new and different and so on. Mm-hmm. All the way back to the people that are still slugging through with the tried and true, and not bad, but I never say that things like monoliths are bad, but they're doing that, right? That we've been doing for decades, actually.
It's the legacy.
So yeah, the legacy in a way. But even now, microservices, I'm starting to think of that as a bit of a legacy also. So the other thing is I love doing talks that are architectural, and I love doing talks that are visual. So I took a chance on this presentation. I've done it in a few other conferences where it's all 3D. So 3D visualizations. And it's so it's kind of a 3D journey with pictures, and it's all pictures. Not words. I'm not showing any code, but it's kind of architectural concepts visualized, and that's been the fun part. Is trying to help people kind of think about different aspects of the architectural landscape, the journey that we're on, and perhaps say maybe you're just starting to get into microservices, and I talk about some of the interesting architectural considerations of microservices. And then
could you just give us a peek into that? So what are some of the important architectural considerations when you go from monolith to microservices?
The biggest one, and this is one that's sometimes hard to get across, and this is one of the reasons I wanted to try this experiment with more of a visualization, is that when we move to say a nice tightly coupled monolithic world, with well-crafted tools and highly refined tools, and we move into kind of a rough and ready microservice world, often a lot of people carry forward the thinking that they did in monoliths into microservices. And one area that I kind of focused on is how do microservices interact with each other. So the very typical approach is that say microservice A does some kind of a RESTful request to microservice B. Really easy to do. There's great tools to do that. But what I'm trying to point out is that's a form of a remote procedure call. Yeah. And it's something that is potentially difficult as a form of coupling. There's a whole raft of reasons why there are alternatives to that might be better to consider. Don't automatically assume that you just move from this tightly coupled monolithic world to what some people call a distributed monolith in a microservices world, and you're wiring all your microservices together with remote
with REST APIs.
Yeah, with REST APIs. So the alternative is to start to think much more asynchronously, and I try to point out some of the advantages. Things like, first off, in production, the microservices are very loosely coupled. So if microservice A does not depend on microservice B to complete its work, and microservice B goes down, microservice A doesn't care. That's a really nice place to be, because now the system is less brittle in a way. The cascading failures and things like that. Circuit breakers and everything are great, but circuit breakers just say, oh, stop beating up microservice B because microservice B is down or is struggling to come back up. And if you're hammering it with requests, it's not going to help it come back up. That's what's great about things like circuit breakers. But fundamentally, you've got a potential issue there. And another thing, though, is just, I try and point out visually that each microservice should be totally self-contained. There should be an outside perspective of a microservice and an inside perspective. And this try and builds on the loose coupling part of it. And it's not just a code that's part of the internal black box of a microservice, but it's the data, which is often much harder to do. And I love bringing this up in talks because it gets people thinking. And I'm pointing things out that maybe you can't do it. Maybe you can't convince your DBAs and the teams that are responsible for your databases, the monolithic databases, to break them up. But at least you're planting the seeds. A thought of that we are moving from, say, tightly coupled, kind of remote procedure call, monolithic databases, monolithic chunks of code, to much more fine-grained, because that leads into the brave new exciting world of serverless, and things are really exciting there.
So talk to us about serverless, because it's a bit of a misnomer, right? So you still got servers, you just start dealing with them.
Yeah, and there was a big advantage of doing the kind of the visualization, because I spent some time with in the talk showing that one way to think about the difference between the serverless and pre-serverless is in the way it handles capacity.
Yeah.
And before serverless and with capacity, you can really think of capacity as a two-dimensional thing. On one dimension is the CPU or processing capacity, say that's the x-axis. And the other dimension is the memory capacity, the y-axis. So historically, and I've been doing this for a long time, we always had to think about how much capacity do we actually need? And as I was preparing this talk, it really came to me, he's like, yeah, we're just basically laying out this two-dimensional grid. How much CPU do you need, processing power? How much memory capacity do you need? And then that was kind of fixed. And you were paying for it. And this is even true in a cloud. When you get virtual machines, maybe you have a little bit of elasticity, but for the most part, people don't. You go to serverless, and the reason they call it serverless is you don't have to think about that anymore, because all you're doing is you're writing the code. You're kind of saying, hey, serverless environment, here's my function. I want you to run it. You can scale up to this amount, but you can also scale back when you don't need it. So the whole pricing model has changed from kind of a fixed price, you always pay for this amount of computing capacity, to a very variable price.
It's like on demand, right?
Exactly, on demand. So it's a totally different new world. There's there's a lot of material that's out there about things like, well, it's more expensive for some people when they go to serverless versus when they, I'd say, that a comparable application built maybe with microservices or monolith, but everything is new. And other people are saying, no, this is great. We really are saving a lot of money because we're only paying for what we're using when we're using it, and not paying for anything when we're not using anything. So that's a huge change. But it also, it's kind of taken so much, I kind of call it friction. And really, I think the better term for serverless is frictionless. Meaning that all the things that we had to worry about, like how much processing capacity do we have, what's the technology that we're running on, even Kubernetes, which is wonderful. A lot of the Kubernetes abstraction still leaks into our conscious. We have to deal with it as developers and architects. You go to the service world, and a lot of those things are gone, and you're really just, more and more and more, you're focused on writing code for your application, not everything else.
So I'm glad you kind of talked about that one. So is the fact that we're kind of moving to this frictionless world, is that the reason that the rate of change of this evolution of going from monolith to microservices to serverless to whatever's beyond, is that the reason that the rate of change is accelerating?
I think it's the new big factor that's contributed to the never-ending acceleration of change. We've talked about exponential acceleration of change for decades, and to me, I think it continues unabated, and it's speeding up. Mm-hmm. And this is a perfect example of something completely new that's absolutely speeding up the rate of change for a whole bunch of reasons, like less friction for building applications. But another thing I think that's really significant, and this is going to be fun to watch, and it's already happening, is how much easier it is for each of us as individual developers to become familiar with it to the point where we're proficient. Because in a serverless world, you can take your own personal account, go to your favorite serverless provider, start playing with it yourself. And when you're not running anything, you're not paying for anything. So you could start up an app, you could even spin it up some really high volumes, see how the application behaves, play around with it, learn about how can I build, high volume, high performance applications, and then turn it all off, walk away from it. That's a
really cool concept. Pay as you go.
Yeah, exactly. And I think it's going to have that really significant impact on developer adoption. Mm-hmm. Comparing that to, say, coming up to speed on microservices, which was much better than coming up to speed on Monolith. But even there, you had to have kind of an investment in some kind of an infrastructure mm-hmm. to really do like full and then development testing, maybe production load testing, and that finally going into production. Okay. The cost of adoption, I think, is dropping significantly.
Mm-hmm. Okay. So I'm kind of curious. So can you look into your crystal ball and tell us? So because your talk goes from monolith to microservices to serverless and beyond. So what is beyond?
Well, I don't know if I want to tell you because I don't want to give away the best part.
Okay, just give a sneak peek.
I'll give you a taste. One area, I kind of covered two areas, and I think there's going to be a bunch, but there's two areas that I kind of focus on. One is that I think that the types of things that are going to come out are going to feel much more organic. And this is already happening in things like Amazon, where you're creating functions and then you realize that you can have functions that feed functions that feed functions that feed functions. And there's this kind of, I hate to call it streaming because I don't think it is kind of a form of streaming processing, but to me, it feels almost more organic in that these things naturally start to work together. Your head starts to think more naturally in that way, which is, I think, a kind of a natural way for us to think as humans about solving problems. So there's that. And I think I said, I use an example of the movie 2001, which mm-hmm. Was over 50 years old now. And I admit I was a kid when I saw it, and it just rocked my world. And the predictions of what things were going to be like in 2001 back in 1968 were completely off, right? So, I mean, some things are true, but most of it's not true. In any case, predicting the future is, fraught with folly, right? So anyways, I think, though, that things are going to evolve very, very quickly, and we're going to get into a kind of a more natural, more kind of intuitive, very interesting new patterns of processing will emerge. That's one. The other one is that some of the things that we're working on at Lightbend, Microsoft is working on some things. We had a symposium a few months back that was going to be face-to-face, but it was scheduled right at the beginning of all what's going on now. So it became a virtual one. But you had all these different organizations that were talking about stateful serverless. Because right now, everybody's talking about stateless serverless. The stateless is a pattern that fits nicely with the state-of-the-art of much of serverless today. But what's happening very, very quickly is people are looking at a more stateful kind of an approach. And
what's the benefit of that?
there's a number of benefits. I think that the two are that the costs can go down. Yeah, that's one of the big goals, because your functions are running more efficiently. Because you're paying, when your function's alive, if it's waiting for, say, an IO to complete, the meter is running. Right? So if you have functions that not only compute less, but weight less, they cost less. So
say that again, when they either compute less or
weight less.
Weight less.
Weight less time, for like IOs to complete or something like that. So that the actual time from, say, request coming in to response going out, you optimize that as much as possible. There's an economic benefit to that.
Okay.
The other one, of course, is performance as well, because and this is what is some of the work that's going on, the more that you can actually pull into memory and keep in memory for a long time, for maybe as long as it's actually needed, and do it reliably and all the other things, then the performance goes up. That often you run into say performance thresholds that maybe just fundamentally are due to contention. There's so much contention on the underlying database that the database itself could be on a very, very powerful platform, but everybody waits behind locks at the same speed, right? When if locks are slowing you down on the database, no amount of power is going to get you out of that. And it's these kinds of approaches that are happening, and it's amazing. And I'm just watching just the work that's happening in Lightbend, and it kind of, for me, it sprang out of nowhere last year, and now these guys are screaming along. There's something that's been released. Microsoft has done some amazing work as well that they've released, and these things are just appearing just so quickly, and they're amazing pieces of work. They're very, very interesting things that are coming out in that world right now.
Well, it sounds like a fascinating subject, and look forward to actually hearing the full thing in later in the year, in fall. Before I let you go, I have to ask you one non-technical question. So I heard, obviously, you mentioned that you did travel a lot. What are your top 3 destinations that you've been to?
I love Prague.
Okay, beautiful city.
And any excuse to go to London. And I guess it's a hard choice, because I've been lucky. There's been so many other places. Amsterdam,
okay,
is a wonderful place as well. And I've been lucky to be, in the last few years, have gone to many of them multiple times. So, and I thoroughly enjoy it. I really miss being out on the conference, speaking at conferences around the world. I really miss it.
Hopefully it'll come back soon.
Yeah.
Hugh Mckee, it was a real pleasure speaking with you. Thank you for giving us your time.
You're welcome. Thanks so much for taking the time to talk to me.
Thank you.